let us start this lecture with a thought process, that is, our unwanted wants snatch away our peace of mind. It is very important to lead a peaceful life for achieving excellence in life, and nowadays we are really running after or chasing the unwanted things throughout our life. And let us recall what we learnt in the last lecture. In the last lecture, we discussed about the multi-staging rocket engines or the vehicles, and we learnt why we will have to go for the multi-staging rocket engines, and three kinds of multi-stagings we have discussed, and we found out also how many number of stages one should use such that one can achieve the higher velocity and without really complicating the process. We learned that around 3 stages can be used for getting maximum benefit out of multi-staging. Today we will be discussing about the chemical propellants and also various kinds of propellant that is being used in the rocket engine. We will be discussing. A question might be coming to mind, what is a propellant? It can be really defined as the material or the substance that can propel a vehicle or a mass or an object. So, in that sense one can say that that should have certain amount of energy which will make it to propel or so that it can have a motion. Even like your air at high pressure or any other liquid at a high pressure can be used as a propellant, although it may not undergoing the chemical changes. And we do use that in our case, like if you look at that air, high pressure air can be utilized, so also high pressure liquid. And chemical propellant is the one in which the chemical reactions will be taking place, releasing certain amount of heat, and can be converted into high pressure gas, which can be expanded in a nozzle to produce thrust. We have already discussed about it. Generally a question might be coming to your mind, what do you mean by chemical propellant? And chemical propellant basically consists of 3 major components. One is fuel, other is oxidizer and additives. Of course, we are aware about fuel and then oxidizer, but a question might be coming, why do we use additives and for what? As we go along, we will discuss about the additives and its utilization. And if you look at a fuel, and we know that we use generally the hydrocarbons as a fuel, and both the fuel and oxidized additive can be solid or it can be liquid, it can be gaseous, it can be various phases, it can also be gel. And all these fuel and oxidizer and additives, in other words the chemical propellant, has to be basically burnt and producing certain amount of energy such that high pressure temperature gas can be generated, which can be expanded in nozzle to produce the thrust. The example of fuel in case of rocket engine is basically hydrocarbon, hydrogen and polymer and cellulose and several of them. These are generic fuels, but various combination and then fermentation one can make various kinds of fuel. And oxidizer, of course, the oxygen is one of the important oxidizer, and which we use as a air in air breathing engines, but in case of non-air breathing engine or the rocket engine, we will have to use oxygen, because as we are carrying the oxidizer along with the fuel. So, therefore, it is not advisable to really carry the air with the vehicle. And beside this, chlorine, fluorine, ammonium perchlorate, nitric acids, and several of them can be used as an oxidizer, we will see. And a question might be coming to your mind, what is the explosive, whether the propellant can be explosive, act as explosive. So, explosive could consist of chemical propellant. That means, it is a special kind of chemical propellant which will be have certain high burning rate, or it will be high energetic material. And keep in mind that in case of explosive, that it contains the fuel and oxidizer in a single mass, such that mixing between the fuel and oxidizer will not be a problem, it will be already mixed, and also it will be ignited and it will leading to a very spontaneous chemical reaction, and which will be occurring at a very rapid rate as compared to the general chemical propellants. So, in other words, explosive is a chemical propellant that has inbuilt oxygen, as I had told you that it will be in a single component, sometimes in the single it will be mixed at the molecular level. And generally we will be discussing mostly about the chemical propellant. Sometimes some of the explosives which use as a propellant can also be discussed. And keep in mind that explosive can be divided in two categories, one is primary explosive, other is secondary explosive. And most of the propellant will be undergoing the deflagration, the combustion, which is a subsonic combustion. So, therefore, that is will be discussed in our lectures, and whereas the explosive undergoes the detonations. And similarly, the combustion can lead to the detonation, or deflagration can lead to the detonations, that is known as secondary explosive materials or explosion. So, a question arises, how to choose the propellant for a particular mission. In other words, what are the criteria for choosing proper propellant for a particular mission. So, we as we know that it will be having several of them, and one important one is the heat release rate. That means, the propellant must have a higher heat of combustion, so that you can have a high gas temperature. And we have already learnt that to get a higher exhaust velocity from a nozzle, we need to have a high temperature and so also the high pressure. And the molecular mass of the propellant also is one of the important criterion has to be looked at, because of fact that lower molecular mass of the propellant can provide us, propellant means of the gases of the combustion gases, can provide us higher ISP. And beside this, the propellant density is also one important consideration, because the density of the propellant is higher, such that we can store the propellant in a smaller volume. We can store the large amount of propellant in a smaller volume, such that we can have a compact engine. And beside this, the fuel and oxidizer should remain stable over the period of time, so that its chemical, physical properties will not change, and it will be easier to store, and also the corrosiveness and toxicity also two criteria to be considered for choosing the propellants. And last but not least is the cost, which is of course may not be important for military application, but however for civilian application the cost is very important, particularly in recent time, as the number of missions are being increasing, particularly for in our country. So, therefore, it is important to choose the propellant such that cost will be minimized. So, let us look at general characteristics of chemical propellants and which will be valid for solid and liquid and the gel. And as I told earlier, the propellant must have high chemical energy release, in other words higher heat of combustion, so that it can produce higher combustion temperature leading to higher characteristics velocity, and higher characteristic velocity can lead to a higher specific impulse. So, therefore, we can achieve better performance of the rocket engine, and it can have a low molecular weight of the combustion product, because if you look at VE or the exit velocity or the exhaust velocity from the nozzle is inversely proportional to the molecular weight. That means, smaller the molecular weight, exhaust velocity will be higher, and if the exhaust velocity from the nozzle is higher, then naturally the specific impulse produced by the rocket velocity will be higher. Hence, generally the hydrogen and lithium, boron, beryllium materials are being to be used such that the molecular weight of the product gases will be lower to have a higher exhaust velocity, and it can have a high density such that the large amount of chemical energy can be stored in smaller volume, and hence we can have a compact engine, and that is one has to look at it. So, it is easy to ignite even under the low pressure condition, because we have seen the multi-staging. In case of multi-staging, ignition will be taking place at a high altitude and a high and low pressure, and keep in mind that it is very essential to ignite it quickly, otherwise it will miss the mission path which is supposed to be adhered to. So, then your target may be missed, and then it will be really of not use. So, therefore, it is ignition is a very important part of the or criteria of the chemical propellants, and you might be aware some of the earlier failure in the spacecraft mission is attributed to the mal-ignition of the rocket engines, particularly during staging. And the propellant must be physically chemically stable with respect to time, otherwise it will be not much use, because of fact that suppose you have stored the solid propellant which will be used in a missile, and it has been deteriorated and it has been physically or chemically damaged, then naturally when it is fired it not be performing well, and then your mission will be failure. So, one has to be kept in mind, generally the solid propellant is kept for years together. So, one has to choose the propellant such that it should have a higher stable life, and it must be smoke free and non-toxic in nature. That means, the gases coming out due to the burning of the propellant from the nozzle must be smoke free or the non-toxic in nature, because of fact that then it will be detected by the enemies, and also it may affect the people and also environment. So, therefore, one has to choose the proper propellant, so that it will be propellant with having smoke free and non-toxic in nature. And propellant will be chosen such that it is easy and less expensive to manufacture and handle during operations, so that it will be easier, and that is the one of the important thing. And easily available and having low price, so that you need not to depend on other countries, and also the cost will be of the operation will be reduced, and less prone to the explosion hazard. You might be aware that when this some of the propellant are being stored in places gets exploded, which is occurring nowadays in India, you might have heard, and which is very unfortunate, and we need to choose the propellant such that it will be less prone to the explosion hazard, as it may affect, it may spoil the not only the property, but also the human casualties. So, and another very important thing in modern time, particularly the propellant should have a low emission level. Otherwise, a lot of agencies have come up, they may not allow you to have this operation of rocket engines, because emission is a great concern which has threatened the life existence on this beautiful planet, that is Earth. So, if you look at these chemical propellants can be classified, as I told, there are various kinds of propellants people have developed. So, therefore, we will have to classify depending on the physical entity, that is, as I told, it can be solid, it can be gel, it can be gas, it can be liquid. So, if you look at, it can be also the gas, high pressure gas, that means propellant can be gaseous, can be solid, can be gel, can be liquid. And solid propellant can be divided into two categories. One is homogeneous and other one can be heterogeneous. And the homogeneous propellant is basically one in which the fuel and oxidizer will be mixed at the molecular level, whereas in heterogeneous the fuel and the oxidizer will be mixed at the physical level, right. And this homogeneous propellant divided into again three categories. One is your single base, propellant, and other is your double base propellant, and this is known as triple base and single base. If you look at it, is basically, you can example I can give a nitrocellulose, we call it as a NC nitrocellulose. And it can be decomposed into a product, and once it is ignited, such that it can give you certain amount of energy release, and you can get high temperature and high pressure gas. And double base propellant is one in which both the fuel and oxidizer will be mixed together and kept as one propellant grain, and then it will be ignited. And triple base, where the fuel, the three kinds of base can be used, propellant can be used like fuel, oxidizer, and also the other things, that it will be known as triple base. And most suitable propellant, or the mostly used propellant in case of homogeneous category, is the double base propellant. And in the example is the nitrocellulose and nitroglycerin are being used for producing a double base propellant. And this will be, as I told, that nitrocellulose itself is a basically explosive, and which can be used because it is a single base where both the components of fuel and oxide together will be there. And double base propellant again can be divided into two categories. One is extruded double base EDB, and there is a CDB, that is your cast double base. This is your extruded double base propellant, and this is cast double base propellant. And this is the divided based on the method by which the grain is being produced from the propellant. And keep in mind that the heterogeneous is also known as composite propellant, and composite propellant is being used very much in the solid as a solid propellant, because it is quite stable as compared to the double base propellant, particularly for bigger applications it is being used. And keep in mind that again you can have extruded composite propellant, and then also you can combine this double base and composite propellant is known as combined composite propellant. Keep in mind that various kinds of permutation combination one can have, and then we are having, and if you consider this heterogeneous combustion, it is also heterogeneous propellant is undergoes a pre-mix combustion type, and composite is a both the pre-mix and diffusion flame based combustion will be taking place. And coming back to little bit about gaseous, it can be a inert. Gaseous propellant can be in two categories. One is inert propellant, and other is the chemical propellants. And the gel, of course, various kinds of gel being used, because the gel propellant is having both the advantage of solid and liquid. It will be in between. It will be thixotropic gel which is being utilized, so that when the it is subjected to pressure, then it will be converted into liquid, and then this liquid can be atomized and you can use it, you can use as a propellant. So, it can be basically if you look at gel propellant can be also divided based on the liquid, because gel is generally prepared from the liquid propellant. And the liquid propellant can be divided into two categories, and one is your hypergolic propellant and other is your non-hypergolic propellant. Hypergolic propellant means when the fuel and oxidizer will be mixed together, or then it will be undergoing the chemical reactions. That means the hypergolic propellant will be undergoing chemical reaction without initiation of ignition, whereas non-hypergolic propellant has to undergo the ignition with the help of some external energy. And this again will be divided into two categories. One is your monopropellant and category into bipropellant. And the monopropellant, as the name indicates, that it is basically a single propellant where the both the fuel and oxidizer will be there, and such that it can really undergoes the chemical reactions. Of course, maybe some of the catalyst will be used to initiate the ignition, and depending on whether it is hypergolic or non-hypergolic. And the monopropellant again divided into simple one and it is divided into another categories like your solid, it is a composite propellant. The simple one is you can think of something methyl nitrate, which will be undergoing decomposition whenever it will subjected to some kind of a catalyst, and then you can get a high temperature high pressure gas. Composite, you can say amyl acetate or nitric acid or any other things which will be can be mixed together, can be used as a propellant. And bipropellant is basically will be two kind of it will be consist of both fuel and oxidizers are used separately, and then it will be mixed and it can be used. So, example of fuel, some UDMH unsymmetrical dimethyl hydrogen, which is used as a fuel, and RF and red fuming nitric oxide is used as oxidizer. There are various kinds of fuel and oxidizer will be there. And keep in mind, this bipropellant can be hypergolic, it can be non-hypergolic. So, we will be discussing more about these propellant types as you go along. Keep in mind that depending on this liquid, we can have various kinds of gel propellants, and which is gel propellant is not being used in the regular flights. However, lot of research is going on for the gel propellants, as it is advantageous over the liquid propellant, and it is envisaged that one can get a higher specific impulse provided load the gel with the metal powders or metal powders, such that the higher ISP can be obtained. So, with this I will stop over here. In the next lecture, we will be discussing about more about the solid propellant, and then later on we will be looking at the liquid propellant in detail. Thank you very much.